We're going to start today by hearing from Dr. Hilde Stenuit, who is IceCube's business development leader for space application services. And she's going to sort of introduce us to what is crystallization and what is some of the work that she's been focused on from a space application services perspective. Hilde Stenuit received her MS in Mathematics and Applied Physics and PhD in Plasma Astrophysics from KUL, and has worked in operations for the European Space Agency, and since then has been really using her expertise to guide users and create opportunities for commercial access to low Earth orbit. So we're very excited to hear from Dr. Stenuit, from Hilde, right now, and please kick us off, Hilde.
Well, thanks for a great introduction, Cindy. And I'm very excited to be here, and you've done almost all of my introductions. So as you rightfully said, so I have a research background, but not one that is related to proteins or viruses or inorganics or crystallization, but rather to astrophysics background. And so I started working with space application services, and I supported indeed the European Space Agency for quite some years, also in a function of mission science office, coordinating with the different agencies on the different science disciplines on the International Space Station. And now indeed I am supporting our IceCube's service. And for those that are not familiar, our IceCube service stands for International Commercial Experiment Cube Service. So it's in Europe, it was the first commercial access service for research and for technology. And you see some of the pictures of some of the cubes and modules that we fly on a regular basis to the International Space Station for different types of research, different type of technologies. And we provide this service globally. So we work with the European Space Agency in Europe, with NASA and with the ISS National Lab in the US, but also we're very proud and happy to work also with our colleagues from the Japan Manned Space Systems Corporation, JAMSS. And it's one of the partnership collaborations that we're really proud to support, to fly and accommodate this incubator that allows for protein and large molecules crystallization in space. And Sato-san, who's also here with us, will say a bit more about that. So you see that incubator cube that is developed by JAMSS on the left bottom picture, but we'll address it then later on. So enough about me and the service. So I'm grateful to the colleagues from Space Commerce Matters with Cindy and Jose that they proposed to have this webinar. And so the message that we typically pass when we talk to possible users of the service in terms of protein crystallization is that crystals grown in space come out larger and better structured than the same ones on Earth, and they have less imperfections, and all of that can help to reveal the structure and the function of those proteins or molecules more clearly. Now, I have understood that Dr. Ann Wilson and her students have done a retrospective analysis of public domain data of crystals that are grown in microgravity. So I'm surely very eager to learn more from her and on the how and if this indeed supports the value added as we present it and the possible application areas. So with that, I would like to hand it back to you, Cindy, to introduce our main speaker of the day for the keynote.